Hi, everyone. So we are still in Unit 6, and up to this point in Unit 6, we have been dealing with only ionic compounds. And now we're going to broaden the spectrum a little bit, and we're also going to be talking about molecular compounds. In the last video, I discussed with you what are molecular compounds and how do they differ from ionic. Well, today we're going to talk about naming and writing chemical formulas for molecular compounds. We're going to be following different rules from the rules that we followed for ionic compounds. Actually, let's first start by naming some ionic compounds, and then let's move on into molecular compounds. When we move into the molecular compounds, you're going to see why we need to follow different rules from naming ionic compounds. All right, so I have 4 ionic compounds here. I've got sodium chloride, I have calcium chloride, aluminum chloride, and aluminum oxide. Now, I really want to emphasize something here, all right? This is a really important point. There is only one way that sodium and chlorine can come together to form sodium chloride. You can only have a 1-to-1 ratio in sodium chloride. It's because sodium has a positive charge, chlorine has a negative charge, or chloride ion has a negative charge. For calcium chloride, there is only one way that calcium and chloride can come together. Calcium has a 2+ charge, chloride has a -1 charge, so we need 2 chlorides to go with the calcium. And again, for aluminum chloride, there's only one way that aluminum ions and chloride ions can come together. It's a 1-to-3 ratio. Same goes for aluminum oxide. You have aluminum ions coming together with oxygen ions, oxide ions. It can only happen in a 2-to-3 ratio. All right? Since these can only come together in one possible way, then it's okay to just call these sodium chloride, calcium chloride, aluminum oxide. For molecular compounds, the atoms can come together in many different kinds of ratios. Let me give you an example. I'm going to use nitrogen and oxygen in some molecular compounds, okay? Here are 4 examples of molecules that contain nitrogen and oxygen. Here's a molecule which only has 1 nitrogen and 1 oxygen. Here we've got 2 nitrogens for every 1 oxygen. Here we've got 2 nitrogens and 5 oxygens. Here we've got 2 nitrogens and 3 oxygens. All right. These compounds, now listen carefully, this is very important, okay? These compounds do not contain ions. There are no ions here. All right, these are molecular compounds. In the last video, we talked about, you were introduced to the concept of a covalent bond. These are all covalently bonded atoms. They are bonded to each other by covalent bonds. Okay? So now we need a scheme for naming these things, because I can't just call this nitrogen oxide, or this nitrogen oxide, or this nitrogen oxide, or that nitrogen oxide. I mean, I need to be more specific about the numbers of nitrogens versus oxygens in these molecular compounds. All right, so here comes the scheme that we're going to follow. All right. Okay, so in order to count the atoms of a certain element in a compound, we're going to use these prefixes. Mono means 1. Di means 2. And by the way, we're not going to use bi for 2. We're going to say di is 2. Tri, 3. Tetra, 4. Penta, 5. Hexa, 6. Hepta, 7. Octa, 8. Nona, 9. And deca, 10. Make sure that you've written this in your notes, okay? You're going to want to refer to this when you're practicing naming and writing formulas for molecular compounds. All right, let's try some examples here. I think the best way to learn about this is to just try some sample problems, all right? So here we go. All right, so let's use these as examples. I already wrote those earlier, so let's just use them. I'm going to name this first one. Okay, this is going to be called nitrogen monoxide. Okay, now instead of saying monoxide, we're just going to simplify it and say monoxide, not monoxide, but monoxide. So nitrogen, which is there, and oxygen, okay, we're going to kind of following the same scheme that we used in ionic compounds, but with a little bit of a twist, okay? So I'm counting the number of oxygens there. If there's only one nitrogen, as there is here to start with, I'm just going to say nitrogen. I'm not going to say nitrogen monoxide. I'm just going to say nitrogen monoxide. Okay, let's try the next one. All right, so next one, I'm going to call this dinitrogen monoxide. Monoxide. Okay, for this next one, I'm going to call that dinitrogen pentoxide. Not pentaoxide. When you get two vowels together, we're just going to call it, we're going to drop the A, for instance, with this pentaoxide. It's just pentoxide. So dinitrogen pentoxide. All right. And with this last one, I'll bet you can guess. This is going to be dinitrogen trioxide. Pretty simple, right? Let's try another couple of compounds. How about this one? I know that you've heard of this before. So CO, that's going to be carbon monoxide. I'm sure you've heard of carbon monoxide poisoning. You probably have a carbon monoxide detector in your house. At least you should. Okay. What about this one? CO2. All right. Well, that's carbon dioxide. And I'll bet you've heard of that as well at one point, or many times, I'm sure. All right. Let's try another one. How about this? Carbon with 4 chlorines. That's carbon tetrachloride. Okay. How about this one? H2O. Ha! That's water, right? Well, if we were going to follow this scheme, we would actually call this dihydrogen monoxide. Dihydrogen monoxide. That is water. What about this one? H2O2. Dihydrogen dioxide. All right, so, a lot of these compounds have common names, like H2O is water. H2O2 is hydrogen peroxide. But if we follow this naming scheme, we would call water dihydrogen monoxide, and hydrogen peroxide would be dihydrogen dioxide. All right, why don't you take a moment and see if you can do these 5, or name these 5 compounds. Pause the video and see if you can try this in your notebook, and then I'll show you the answers. All right, so here are the answers. So I'm just going to name it as I see it. I see sulfur first, I see fluoride second, sulfur hexafluoride, sulfur tetrafluoride, xenon hexafluoride, here's chlorine trifluoride, here's diphosphorus tetraiodide. or tetriiodide. I'm going to stick with tetraiodide. All right, I think you're ready to move on to the worksheet now. Do the homework, put it into Notability, and then submit it through Shobi. The worksheet is attached to the assignments. It's also in your binder, but I'm sorry, at this moment, I don't know what binder page it is. It might be like 165 or 167. I can't remember. But it's called Molecular Formulas. It's Unit 6, Worksheet 4. Okay? Thank you, and have a great day. Bye.